a practical guide to connecting hardware to Flex, was presented as part of the Flash in the City conference. This presentation was originally recorded on June 12, 2011, in New York City.
This is like a standard Arduino prototyping board. You know, that's pretty small. Remember this processor on it, it's equivalent to like a 386 processor. This is cheap, costs about $30, $40 US, something along those lines. This design's a few years old. Here's a more modern one.
That's an Arduino?
That's an Arduino. And this is not even the very latest. This does exactly the same as that board there. It's about the size of a postage stamp. It's about just as thin as well. It's maybe a little bit thicker. You can now get the chips this size that have Wi-Fi built into them. So the main problem with the idea of the ubiquitous computing and all these things being everywhere is power. Power is the big problem that they can't really solve. These chips are pretty low power consumption, but they still need power. So hand that around if you want.
How do you connect things to this?
That one you've got to solder up. This is why this is a good prototyping board, because it's got a USB plug and it's got sockets that you can plug things into. Yeah, just
pass this around.
Yeah, pass them around. Cool. It's good if people get to have a look at them. So, I've sort of skipped ahead a little bit. So, the Arduino platform itself is an open source hardware and software platform. Everyone here, I assume, knows what open source software is. Yeah, is everyone familiar with open source hardware and how that? They've got at least one person? No. Open source hardware is a little bit different, because what they've done, and in this case with the Arduino platform, is the actual circuit diagrams and the CAD files to make the circuit board, they've open sourced. So you can take those designs and you can go off and make your own boards. You can change the boards as much as you want. You can the little tiny one that I'm passing around, that's actually from a company called Sparkfun. They took the original design, reduced it down, removed a few things they didn't think were necessary, and made it that size. So that's good. So there's about 20, probably 30 odd Arduino boards out there. They're pretty easy to program. As I said before, you code in C. They're fast. They run at 16 megahertz. Now, that might not sound too fast, but they're a RISC processor, and they can do 16 million instructions per second. Right? That's, for most purposes, that's really quick. You're not going to do full screen video with that. It's not designed to do that, but almost any number crunching you can think of, it's going to be able to achieve. They consume very small power, the Arduino board I'm handing around there at the moment. Depending on what you plug into it, you plug a couple of LEDs into it, it's going to consume 30, 40 milliwatts. They have sleep modes on them, so they can actually go to sleep and wake up, and when they're in the sleep mode, like a single 9-volt battery would probably make them last 1 or 2 months. So, as I said, the power is still an issue, but they're getting there towards solving it. So, the Arduino hardware itself comes in a whole lot of different varieties and shapes. As I said, there's about 20 different boards. Low cost, usually between $20 and $40 US. Very easy to extend. If you've got that board somewhere, you notice that it's got some sockets on the top of it. You can actually make a shield and plug a shield into it. I'm going to show you some of those a little later. So, the software itself is extensible as well. Now, the board itself, what can you do with it? Okay, so you've got a processor, so you can add things up and change numbers and do stuff like that. But it also has a set of digital inputs and outputs, so you can turn things on and off, or you can detect whether something's been turned on and off. And it also has some analog inputs, so that lets you measure light, pressure, any sort of analog input that is a variable. So, and I'm going to show you some examples a little later of measuring light in real time. So here's sort of what some of the Arduino boards look like. So this is the standard prototyping board. This is a LilyPad. Now, LilyPads are an interesting board. They're actually made to be sewn into clothing. And I have here my little Flash shirt. So, now, I wouldn't recommend wearing this at an airport. Let me just... but, right?
I like how the battery is the biggest thing on it.
Yeah, the battery's the biggest thing on it. I did have a smaller battery on there, but it wasn't enough power to power all the LEDs. They're quite bright LEDs. So I should probably, put a buttonhole in there and put it on the inside or something, but I haven't got round to doing that.
That's sure.
Yeah. Pass it around, have a look. So that's no soldering was involved with that at all. That's just using metal thread and a needle. Again, my coding's probably better than my sewing skills, so but it works, and it's good fun. So, and there are other form factors as well. This is a larger chip that has a whole lot of more digital inputs and outputs, so you can control more things with it. And here are the Arduino Minis again. These are, as I said, the size of postage stamps, not much thicker. Like you can glue those on a bit of paper. So again, all good fun. So you can really shrink down your project and fit it into something small. You know, you can fit something inside a matchbox, for example. Do they make matchboxes anymore? I don't know, actually. I assume they do. Occasionally. Okay, so the hardware is extensible. So you can actually plug things into the top of the Arduino board as well. I've got here, actually, I'll just grab another one and I'll hand it around. Did have one here. Don't worry about it. Anyway, after I give this a demo, I'll pass it around. So you can plug shields into it. So the shield extends the board with some hardware. So you can get a lot of different shields. There's about 200 or 300 commercially made shields out there. Some of them are in kit form, so you have to solder them yourself. Yeah, sure.
Can you define what a shield is?
Well, it's a lot of the language around the Arduino, because the Arduino is an Italian product, they've translated the words directly from Italian. So shield, I guess, means covering, and they've just used the English word. So a shield is that bit there, which plugs into the Arduino like that. So this is one I've made myself, but you can, as I said, there's a whole lot of commercial shields. And the shields can do everything from control motors to GPSs to 3G phones. You can actually get one with SIM cards in them, voice simulation, MIDI controllers, DMX light controllers, you name it. It's like there's huge numbers of them out there. So here's just a couple of the shields. So here's an Ethernet shield, which I didn't mention. This is a prototyping shield, so you can just quickly whip some circuits together. This is a GPS shield. GPS is really good fun to play with, but it's not very good for demonstrations, especially in a place like this. You don't get any signal. So, and here's a homemade shield. So the software platform, it's open source, cross-platform, works on Linux, Macs, and that other operating system. It is currently alpha, but they're up to version 22. Version 1.0 is going to be out real soon, like in the next month. And it's stable as. I don't know why they bothered to keep it, calling it alpha. Anyway. So it's updated very, very frequently, and there is a growing community around it. Basically, if you have an idea that you want to do with an Arduino, just have a search around and you'll find that someone else has probably already done it, and they'll have the source code there freely available that you can take and modify and use. Almost all the source code out there is open source. Right? The Arduino itself is open source, and they encourage any of the software that's written for the Arduino platform to also be open source. So I'll actually get to the code in a little bit. So it's actually C and C++ under the hood, but it's not scary. They've tried to make it as simple as possible. They don't use templates. They don't use pointers. They don't even use the new operator. Right? So if you know Java or ActionScript, you can definitely code in this, no problem at all. There's a whole lot of libraries. Well, first off, there's a whole lot of inbuilt functions that you can either turn things on and off, detect whether things have been turned on and off, or detect analog inputs, so light and pressure and temperature and things like that. There's also a whole lot of libraries that it comes with that do things like controlling LED matrices, LCD displays, Ethernet, which I'm going to show. And once a program's uploaded, it's actually permanent. This is non-volatile memory. Right? It doesn't have a huge amount of memory on it. The program space is a maximum of 32K. That seems like nothing, but most programs compile down to 4 or 5K. A web server, which you can write in 20 lines of code, is 6K. It's like absolutely nothing. All right, anyway, I think it's time for some code. So let me... is it working? Yeah. Oh, that'll do. So I'll just show you how easy it is. So this is... no, we don't want that one. Sorry. Yeah, we want this one. Okay, so here's some Arduino code. This is not a very large program, and basically what it's doing is just turning some LEDs on and off. Now, as I said, the syntax is C-style syntax, so it's a little different if you code in JavaScript or ActionScript, but it's not that different. One thing you'll notice is that there's these two main functions, one called setup and one called loop. And what happens is that the setup function is called every time you turn the device on, or the first time the program is loaded to the device. So that's a good place to initialize things. And then you have a loop function, and the loop function does exactly what it says. It then, after it calls the setup, it jumps into the loop function, runs through the loop function, exits the loop function, calls the loop function again, and just loops around and around and around and around. So it's an infinite loop. But you're not designing things for the desktop, and this is actually a good way of doing it. So I'm going to upload this program to this board here. So I just plug in the USB. Yep, thank you very much. And all you have to do is make sure you've got the right board selected, select the right serial port, hit the upload button, and the little lights, actually I'll just pull that off. Yeah, the little lights on the board will flash on and off, showing that it's been uploaded. Okay, that compiled down to 2K, if you can see down the bottom there. That's uploaded, and if I just plug this shield back in, you should see some pretty lights. Okay, so it's really, really simple. It's like, is anyone confused by that code? Does that look complex to do? Yeah, sure. Yeah, okay. I've just unplugged the USB from that.
So if you screw up because it's 4 o'clock in the morning or whatnot, do you have to buy a whole new board? Or you can
No, look, the boards are really. I have, touch wood, I have not broken a single one in like 3 years. They're really robust, and I've done stupid things with them. They're like by permanent it means that the program is permanently on the chip, but you can then upload another program and overwrite that. So if you no, it overwrites it every single time. So this doesn't have any power now. If I plug some power into it, that same program will start up and run. Yep, there it goes. So, yeah.
So that's an IDE that you download and install, and then you just...
Yeah, the Arduino platform includes the hardware, the software, which is the IDE, and all the libraries that you use. And it's free.
Did you ever use that with L-Wire?
Yeah, I've used it with L-Wire. L-Wire is pretty cool stuff, but it's not very bright. That's the problem. And it's a bit tricky because you've got to have certain set lengths. And it also likes interfering with other electronics that are nearby. But it's in the right circumstances, it can be good. So, are those slides up there? No. Okay. So, just in case my demo didn't work, there's a bit of video for it. I have to say I've had more trouble with projectors than I had with these dodgy bits of handmade equipment. So there's a few issues with the Arduino platform. Debugging can be hard. Right? You load your program up onto a device. You've got no visual indication. You can't set breakpoints. You can't look at variables. You can't do anything like that. It's got the equivalent of trace statements, which get sent back over the serial port, over the USB port, and that's good enough for most debugging, but it still can be a little difficult. There's no simulator. That is actually done on purpose. The hardware is cheap. We're not talking about a $1,000 new mobile phone or tablet here. They're $20. It's like, just use the real thing. There are limits to memory. You've only got 32K of memory. You can't store large amounts of graphics with text in there. You can actually talk to SD cards and get stuff off SD cards, but that requires a little bit more electronics knowledge and or a shield. It does help to have a little bit of electronics knowledge, but it's not essential. As I said, I don't have a background in electronics. I didn't study at university or anything like that, and I'm now fairly comfortable, soldering together own little boards and so forth. Some of the time I don't know what I'm doing and I stuff up and it doesn't work, but that's okay. So that's sort of the basic overview of the Arduino. Is there any other questions before I carry on and say how we start going to communicate to it from Flex? No? All good? Great. So there's actually quite a few ways that you can connect an Arduino to a computer. So far I've showed you, direct to the computer via USB. There's also a whole lot of wireless ways you can do it. There's a thing called Zigbee modems. They're absolutely fantastic. They're little postage stamp size modems. The more powerful ones have a range of 1 kilometre line of sight. They automatically form self-healing mesh networks that will route packets by themselves. You can actually send a message, pull the modem physically out of the socket, plug it back in, and the message will still get there. Right. Really great little devices, but I'm not showing you them today. I'm going to show you direct to the computer via USB, and I'm also going to show you Ethernet. Another way that's just becoming more popular at the moment is via the cloud. You should have a look up PatchBay. PatchBay provide an online service which is an infrastructure which will actually poll an Arduino that's been plugged into the internet and then store and record all the sensor data for it and then make that data publicly available. It's PATCHUBE. There's also, you can communicate it to an Arduino in a lot of languages. I'm going to talk about Flex. Everything that I show today you could do with Flash as well, other than the fact I'm using MXML. But also processing, Python, Ruby, Java, C, C++, C#, Objective-C, .NET. And there's even a few weird ones as well, like Perl, Mathematica, Second Life. Second Life, that just really does my head in. It's like you've got someone playing a virtual avatar in a virtual world, interacting with a virtual thing that then could actually affect something in the physical world. It's just bizarre.
I like to write a thesis.
It probably is. So, yep, we're talking Flex. So, Flex, as you know, when you write Flex code, MXML gets converted to ActionScript. The ActionScript gets compiled into a Swift. The Swift runs in the Flash player. The Flash player runs in a virtual machine. It doesn't have any access to the hardware. It can't talk USB ports, right? So we've got to do something to try and fix this. And what we need to do is we've got to set up these several layers of communication. So what Flash does really well is talk sockets. So that's good. We can do that. So what we then need to talk to an Arduino connected to a USB port is a socket to USB proxy. And it happens that there's quite a few of them around. They were not written for this purpose in the first place, but they work. So that's what we're going to use. And then you're going to need some software running on the Arduino to handle messages that come in and send messages out. And you're going to need something else on the Flex side that decodes those messages and so forth. Luckily, this has all been done for us already. The Arduino comes with, I'll just go to the next slide here. So this is what it sort of looks like. So we've got a computer over here. We've got our Flex code. We're going to use a library called AS3 Glue. It's open source. It's really nicely written. It reacts to events and it works exactly the way as anything else, like clicking a button inside Flex works. That talks TCP/IP to a USB proxy. We're going to be using SIR-proxy. That talks over the USB cable to an Arduino, which is running Fermata Protocol. So let's go through that. Okay, so first up what we need to do is plug this Arduino back in here and upload the Fermata Protocol. So, and as I said, it's one of the standard libraries that comes with Let me just find it here. Examples. There we go. Fermata, standard Fermata. So the Fermata protocol is actually based on the MIDI protocol. It's a binary protocol. It only has 1 or 2 bytes each message that goes backwards and forwards. It's very fast. So that's not uploading. Just give me 1 sec there. Okay, just try that again. Good. Okay, that's uploaded and that's working. So that's now running on there. So that program is now running on this Arduino, but it's not doing anything. We're not telling it to do anything. So we've then got to make it do something. So the next thing is the the SIR proxy. And I've just got one set up here that I've run. It has a configuration file. The configuration file can be a little tricky to set up. The easiest way on a Mac is to find out what the serial port is, and for each different Arduino that you plug into it, you're going to have to put another serial port in there. If anyone's trying this at home and has problems, just send me an email. I'll sort it out for you.
Is there any way to load that proxy onto the USB device, and when someone plugs it in for the first time, it installs that for you?
Not off the top of my head. So the next thing is... Okay, so what we've got here is some Flex code. We've set up some variables for the LEDs. We create an instance of the Arduino class. We request the firmware version. It takes a little while to get set up. It's a couple of seconds. Once we get that message, we send, okay, that's all right. Let's go and initialize everything. So in this case, we're just turning the digital outputs on an Arduino are dual purpose. They can either be inputs or outputs. So in this case, we want to set them to be outputs because we're turning LEDs on and off. So we've got that, and then we've just got a couple of little methods to turn a LED on, to turn a LED off, and then a form with some buttons in it, and that's it. So fingers crossed, if I run this. All right, I'll hold that up there. Give it a couple of seconds. On. Oh. On. Yep. Off. On. That's working? Yeah. So that's in a few lines of code. There's really only 5 or 6 lines of code that matter in that Flex program. I've been able to talk to a physical device and turn things on and off. And it's easy. Anyone can do it. It's not hard at all. Yeah, the Arduino class is part of the AS3 glue libraries that I've imported up here.
So there's like specific commands that you can just tell it to run at.
Yeah, but it basically has a one-to-one mirroring of the commands and the libraries in the Arduino platform. So there's basically turning things on and off for digital outputs, setting the mode whether it's an input or an output, determining analog input values. But the good thing about it too, it has a reporting mode. You can say, and I'll show you this in a minute, but you can say, if any of the digital inputs change, send me an event. And you just have to listen for the event and then it all happens. It's all asynchronous, which is just great. You don't have to do any polling. You don't have to sit there and say, have you changed, have you changed, have you changed?
So there's built-in code on the Arduino in addition to what you personally...
Yeah. So what I've done with the Arduino is I've uploaded a library called Fermata, where that's the protocol, the standard Fermata library, which uses the Fermata Protocol, which is based on MIDI. So it's sending little messages backwards and forwards saying, turn digital pin 5 on.
So what's actually handling those messages on the Arduino side then? Like, so Fermata is the messaging protocol, but is it also has the mapping of what those messages do?
Yeah, there is. And the thing about the protocol here, just give me a second. All right, so this is the code. This code is a little bit complex, but this is what's handling. So this is basically it's a big case statement. It's saying, if it's a digital pin, then set the pin mode to an input, write that. And you can actually extend this and add your own cases and so forth if you've got some custom hardware you want to try and control.
Gotcha.
So it's not that complex.
Yeah. So you don't have
No, it's got some handling that handles basically everything that's default. If you need to turn anything off, we'll read any sensors. If you want to do something more like than say, you want to do some motor control. Controlling motors is a little tricky, so you might have to extend it and change it a little bit. Or if you've got, say, accelerometers that you want to talk to, you might have to write your own custom messages for that. Okay. Let's get back to my slides. So yeah, just going through the digital outputs with AS3 glues. It's as simple as creating an Arduino instance, waiting for the firmware version to come back to you, set the pin modes on any of the digital outputs. So you're saying that the pin is an output rather than an input. And then if you want to turn something on, you just say write digital pin number, and then hi. If you want to turn something off, it's write digital pin Arduino.low. It's really easy. Okay, I'm going to do some analog inputs next. So let's... so we don't need that anymore. Now, I'm going to plug another Arduino board in here. And this Arduino board has another shield on it. And because I'm using another Arduino board, I've got to change the SIR proxy setup here. And it has to use a different serial port. But luckily I know what it is, and I'll just do that. Shut this one down. Run it up again. That's what we want. Right, so let's have a look at this code here. So what we've got here is oh, sorry, you can't see that. Why can't you see that? That's better. I could see the code. So we've got some sliders here. We're going to store the values of the sliders. And this code's very similar to before. The only difference is that in our init function here, we're turning analog pin reporting on. So that means whenever the analog values change, it's going to send us a message that says, here's the new value. I've just been a bit lazy there, and we get an analog data event. When we get that, I'm just going to set the value. The values are actually 10-bit values, so I'm dividing by 4 just to make them a little smaller. And you'll see why in a minute. And then down here, I've just got some ellipses, which I've just bound directly to those values. So let's run this. Okay. Let's give it 1 second. Yep. Do you want to have a play? No? All right. So what I've got here is I've got these 3 sliders. Yeah? And if I move the sliders, it changes the... And you can see that's pretty responsive. Yeah, here you go. See, watch the screen, move the sliders up and down. Thank you. All right, so that's shown you the very basics of digital inputs and analog inputs. I'm going to do something a little different next, and that's talk about Ethernet. Right. So I won't bother going through that. It's all pretty straightforward. It's in my it's going to be in my slides anyway. So Ethernet shields allow you to have direct connection to an Arduino. You don't need a dedicated PC. This means you can have lots of devices scattered all over the place, and as long as they have some form of Ethernet connection. Ethernet might be Wi-Fi, might not actually be a physical cable. Ethernet is quite useful though, because what you can do, most of the Ethernet boards are fairly slow speed Ethernet, they're 10 megabits. But with a 10 megabit Ethernet board, the Ethernet cables have 4 wires in them, and you can use 2 of them for power. So you can actually power the Arduino and communicate with it over a single Ethernet cable. And that's handy. So the shields need a little bit of config. This is actually improving in the version 1.0 release of the Arduino platform. The Ethernet library is going to include DHCP and DNS. Currently, it's a bit buggy, so it's better to set your own IP address and your own MAC address. But it's pretty straightforward to do, and I'll show you how to do that in a minute. The Arduinos can actually act as a web server or a web client. So you can have an Arduino talk to a web server and get information from a web server. You can have the Arduino act as a web server, and then you have a browser which talks to it. You can have Arduinos that are all in the same network and communicate with each other. They can send information backwards and forwards. So it's very, very versatile. Here's some of the Ethernet shields. There's probably about a dozen Ethernet shields. They're all basically the same. It might come down to a form factor, which one you actually choose and which one you're using. Does everyone here know HTTP protocol? In, at least the vague bits of it? That's good. Web servers are stupid. They are really, really dumb. They do one thing and they only do one thing, and that is listen for a connection, parse a request, send back a status message. It's actually not complex at all. And with the HTTP request, this is a typical HTTP request. You've got get the resource that you want, in this case index.html, and then the protocol version. And these days it's almost always HTTP 1.1. And then there's a whole lot of optional headers, and then there's an empty line, and then there's a message body if you've got a post request with that. And we can actually take advantage of this to write a web server on the Arduino platform in about 20 lines of code. It's a bit of a hack, because what we do is we just look for the empty line, because that's the important thing. We know we've got to get, and then we look for an empty line. So let's have a look at that code. Just give me 1 second here. Yep, here we go. So here's a web server written in Arduino. As I said, we need to set up the MAC and IP addresses. Whatever you do, don't get the MAC address the same as another device on your network. It's not good. You can do it quite easily, but anyway. So it's as simple as just setting up a server, calling ethernet.begin with a MAC and IP address, and then server.begin. Oops. Let me just scroll down slowly there. So, and then in our loop, we just basically say while we've got a connection, if there's any data available, read a character at a time. Yeah, sure.
Do you have any particular practice you use when you decide what to use for your MAC address?
Yeah, there's a like the address that I've got there is a MAC address for test devices. There's a bit of a problem because there was some Microsoft hardware that got released that had the test range on them when they shouldn't have. But it's pretty unlikely that you'll run into any other collisions there. Yeah, exactly. It's the same as like net10 addresses, like 10.0.0.1. So there's if you look up the documentation on the Arduino, it has recommended ranges that you should use. So we keep looking for a blank line. When we've got a blank line, we've just assumed that we've got a valid HTTP request, and then we've got we just send back a 200 OK that says, yep, everything's good. That's a valid request. And what we're doing here is we're writing out XML, and we're writing out XML of all the analog pins. So that's about 20 lines of code to do that. And then there's a tiny bit of cleanup that you have to do at the end. So you've got to call a flush and stop, but it's not that complex. So let's plug this Arduino in and upload that code. I have to choose the new serial port, and once I've done that, hit upload. And that's uploading. The little lights are flashing on the board there. Yep, okay, that's uploaded. So I'm actually going to unplug it from the USB there, plug in some power, and then plug in an Ethernet cable.
So power by Ethernet is not by default?
It can be, but Mac laptops don't support power over Ethernet. So you actually need a little device called a power injector. And you can do that by hand. You can just cut the cable and put power down 2 wires or do something. You want to hold that for me? Thanks. So we've now got a web server running on that Arduino. And if we have a look at the IP address there, it was 10.0.0.20. So if we just go to a browser and type that in, 10.0.0.20, it might need a reset. Sometimes it's a bit funny when you first load it up. There you go. Let me just try that again. Okay, there we go. I've got a response from it. If I view that response, we can see the XML. So it's as simple as that. Like I could make that output HTML and say, hello, I'm an Arduino or something like that. But actually reporting the physical values is, a bit more interesting.
What are those values indicated?
The values are all the analog inputs. So the board itself has 4 analog inputs. And in this case, I've got one hooked up to a temperature sensor, and I've got one hooked up to a light sensor. And I'm just going to show you this bit of code. So what we've got here, get the cursor out of the way, is a timer where you can see why I'm using a timer and not using the event-based stuff in a second. We're setting up the Arduino. We're adding a listener for the timer. And then every time the timer goes off, we're doing a HTTP call to the Arduino, getting the result back in XML, and then we're just binding that directly to a chart. Again, really, really simple. Not a lot of code there. So let's run this. Do you want to wave your hand over the top of that?
Wait, so are we looking at heat now or light?
Light. So that's light. So if you move your hand over it, yep, and you'll get it in brighter light. It'll go right down. And it's like the response time's almost instant. Isn't that great? Oops. So, I probably skipped a couple of slides here. Yeah, that's all good. Okay, so I'm just going to talk a little bit about the sort of applications that the Arduinos can do. So you can see they're pretty versatile things. They're very easy to code up. So probably a prime example that you could use them for is environmental monitoring. And that can either be indoors or outdoors. And there's a few more. If you can actually think of some really strange things here. For example, if I got a whole lot of these and I put a little pollution sensor on it, you can actually get air quality sensors fairly cheaply. And I gave it to a whole lot of cyclists and said, ride around the city with this on, come back with the data, you end up with a pollution map of a city.
Was there GPS as well?
You could put a GPS in it as well to map exactly where it is. And it's really low cost and quite easy to do. Right? You could... I know another application where they've put them in a field of crops and they've listened for insect sound. And where there's more insect sound, they put more pesticides on it. If there's no insect sound, they don't use any pesticides. So you can see that a low-cost device like this can actually have quite diverse applications. It's just limited by your imagination. As I said, with the sleep modes on these, like a 9-volt battery would make it last 2 or 3 months. Home automation, so measuring power and utilities. If you know how much power you're consuming, right, you're going to use less of it. That's a good thing. Right, it's very, very easy to set one of these up so you know exactly how much power you're using at any one point in time. You control the heating and lights, put a movement sensor on it. When you walk into the room, it turns the lights on. If you walk out of the room, it turns the lights off. Again, very, very, very easy to do. Doing garden watering, detecting, rather than watering your garden all the time, only water it when it needs water. Detecting how much the soil pH and so forth, and telling you where there might be problems. There's actually a commercial product called Botanicals, which you plug into a pot plant, and it hooks up to Twitter and will tell you when your plant needs water. It actually tweets, "Help, I'm dying." So, another application is sort of security systems. Home security systems, location reporting. There seems to be a lot of bike jackets too. There's like little accelerometers. You move your hand like that, a turn indicator on your back lights up in LEDs. I've seen another one that has electroluminous display on the back that measures how fast you're going and displays that to drivers who are behind you. So these are all cool things. I think I'm probably just about out of time. But so why should you actually do this? When you think about it, there's probably not a lot of direct practical applications to your everyday work life. But it does expose yourself to new ideas and new ways of solving problems, and that will make you a better programmer. It involves interaction with the real world. So again, it's good to actually use your hands and get involved in making things like this. It encourages you to be creative. So as I said, it'll make you a better programmer.
And more valuable.
Yeah, and more valuable. But best of all, it's great fun. All right. That's it from me. If we've got some time for questions, I'll go through the questions.
You put hardware casing around it, and it's like you have to order it through some...
The question was, how do you put hardware casing around it? You can buy hobby boxes that you can put these in. So that I don't mind them bare looking, so you can see what's going on and all the rest. But you can make them nice and neat and actually put them in a little metal box and all the rest.
Put them in an Altoids tin.
Yeah, you can put them in an Altoid tin. You've got to use electrical tape first, but so it doesn't short out. Any other questions? Okay, cool. My slides and code are all going to be up on my blog. If you have any questions, just email me. Follow me on Twitter. So, thank you very much. Out.